These days, the underground gets all its power from the national grid. But how does it get from the power station to the tube station? When power stations generate electricity, they do so at about 25 kilovolts. In order to transport this electricity efficiently, it is stepped up to 132, 275, or 400 kilovolts. It is then stepped down closer to the source of consumption. London Underground has 7 points at which electricity is inserted into its power network. These are called bulk supply points, and they take in 132 kilovolts from the national grid and deliver 22 kilovolts into a ring network around London. The latest bulk supply point was built in 2013 at Griffith House, next to Edgware Road Station. This was put in to meet line upgrades that were to follow in the years ahead. The good thing about this ring network is if one bulk supply point should fail, it is possible for the others to pick up the slack. The power network is essentially a 22 kilovolt ring that goes around London with various spurs going off to the extremities of the network. Along the loop, there are distribution points which feed into smaller 11 kV systems. These 11 kV networks are also in a ring configuration that loop in and out of substations. Here is an example of the type of equipment that goes into a substation. This is from a recent project at Liverpool Street, delivered by UK Power Networks. There are 3 2.5 megawatt DC transformer rectifiers which convert 11 kV AC into 630 volt DC to run the trains. 2 11 MVA transformers that step down 11 kV to 430 volts that's used for station lighting and power. There's a whole bunch of switchboards, a SCADA system and a few other systems listed here. The legacy signaling system can also be fed from these substations. These supplies are stepped down and passed through a frequency changer to deliver supplies like 100 volts AC at 125 Hz. Now you might be thinking, well, that's all well and good, but there used to be multiple independent supplies with Lots Road and Greenwich Power Station. What happens if the national grid goes down? Well, hold your horses. We need a bit more background first. Although London Underground was getting most of its power from their generating plants, another source of supply was from the Distribution Network Operator, or DNO. This is the street supply that goes into your house. Originally, this supply was only used for emergency lighting, where 1 in 4 lights were fed from the DNO. That way, if there was a power disruption on one of the supplies, there was enough light for the passengers to evacuate. With the introduction of electronic communication equipment in the 90s, like public address systems and CCTV, a higher quality of supply was needed than what could be produced by Lots Road. So the DNO became more and more widespread. Let's have a look at the lighting model to see what the different scenarios are. Here is a generic ticket hall at 100% output. Here we have a DNO failure. And here you can see what happens with an LUL failure. Most busy stations will have at least 2 electrical intakes, with at least one being from the DNO and one from the 22 kV network, which is called the LUL supply. So if the DNO supply is disrupted, then we still have the LUL supply, right? Well, sort of. There's still one problem. The DNO and the LUL still originate from the same place, the national grid. What happens if there's a big problem? Do the lights go out? Luckily, the engineers have thought of that. Introducing the offline battery inverter, or OLBI. This OLBI works just like a UPS, but a little different. It backs up the essential services supplied by the DNO, like lighting, and it's configured so that if the LUL and the DNO supplies drop, it'll kick in long enough to allow people to evacuate. If only the DNO fails, the OLBI supply won't come up. It needs both supplies to stop. In the meantime, during a power failure, Greenwich will start to spin up to provide essential services to the LUL supply. This is called the Central Emergency Power Supply, or CEPS supply. This takes about 30 minutes to deliver full output, so UPSs are going to use to cover the gap. The CEPS supply is not designed to move trains around, so if the power goes out whilst the train is in the tunnel, it will need to be detrained, which means that passengers have to walk along the track to the nearest station. This is usually the worst case scenario, not because the tube tunnels are pretty dirty to walk in, but because London Underground staff will need to walk these tunnels afterwards to make sure no one's been left behind before the traction current is turned on. This can delay the service for most of the day. But this isn't all theory. We have a real life example to look at in the next video. The London Blackout.